And we're back.
We are back. It's
Welcome
been a while.
back. Yeah, I mean, look, it's a cool 70 degrees here in Southern California. I got my sweatshirt on and just really feeling the winter vibes.
That's awesome. It's 62 here in Dallas, so not too shabby. I think it's going to turn cold later, though.
Don't know what that's like. So, well, anyway, so it's good to be back finally. I know we had a nice couple weeks of a break from, Containers from the Couch. We had some time to reflect and think about the year ahead, and I think we have some really good stuff coming up this year. But specifically for today, what are we talking about today, Brent?
Well, it happened a few weeks ago, but we're finally, we have time on the schedule to really give this a thorough talk. But etcd graduated, and what does that even mean? Like if we talk about this, we talk about it in terms of, oh yay, etcd is now a graduated CNCF project. But I just said a lot of stuff that people may not fully understand what that means. So let's talk about what does it mean to be a CNCF project in the first place? What does it mean to graduate? And like how often does that happen, and what's entailed in doing that, and why is that important for the community? And then let's dive in and let's talk about etcd. And just how running it at scale and all that good stuff.
So maybe we should start with just a round of intros, because we have some special guests today.
So
let's start with Nathan, and then we can move up to Gyuho.
Sure. So I'm Nathan Tabor. I'm a product manager on the Amazon EKS team. Been working at AWS on containers and Kubernetes for the last few years, and really excited to be here today.
Awesome.
Hi, my name is Gyuho, engineer from EKS team. And my current focus is to operate Kubernetes control plane, more specifically operate etcd on behalf of our EKS customers. So I'm very happy to join this conversation, and then look forward to sharing more our experience in operating Kubernetes and etcd at AWS scale.
Nice. That's awesome. So what is etcd and what is the CNCF? I don't know, Nathan, I should probably just ask you, what is the CNCF and what's it doing for us?
Yeah, so I'll talk a little bit about what the CNCF is, and I'll let Gyuho talk all about etcd, because he is far and away the expert in that particular technology. So the CNCF. So the CNCF stands for the Cloud Native Computing Foundation. This is an open. This is a nonprofit organization that's an entity. It's actually a subset of the Linux Foundation, which is a larger nonprofit group that was really founded to help further collaboration around open source software, right? So if a lot of the folks on the stream are probably familiar with Linux, Linux is one of the largest and longest running open source projects in the world. It's a highly collaborative effort, thousands of people working on it, and the Linux Foundation basically was founded as sort of a holding group, a nonprofit holding group that could help organize these projects and help basically help maintain them, help run them, help fund some of the activities, help coordinate the activities around them. And when the Kubernetes ecosystem started to take off, and there's this whole concept of cloud native, and which are projects that are designed to basically help run applications. And I'm definitely butchering that. If anyone from the CNCF is listening and thinks that I butchered the the definition of what cloud native is, feel free to hit me up on Twitter. I won't say that I have the canonical definition of what that is, but effectively this arm of the Linux Foundation. And so a lot of the things in the Kubernetes community, in the cloud native community, a lot of these projects are part of the CNCF. And really what that means is we have two ways of thinking about this software. There's open source software, right? Which is software where the source code is visible to everyone, where you can actually look all the way through the project. You can understand like how the entire thing is created and written. There's nothing proprietary about it. We could spend the entire rest of this time and maybe more days talking about the legal and licensing implications of open source, but to suffice to say, it's software that everyone can see and they can view. But then there's this other concept that often comes along with open source, which is the idea of open governance. So there's a difference between I am developing something in the open, and you can see all the code that I'm writing, and you can understand how something is built, and you can copy it and use it at any point. And you can actually make changes to my project. So I could have an open source piece of software that no one could ever change except for me, and that I'm the owner. I have full governance control over that. And so that actually has really important implications, because if you're building software collaboratively, if you're building software that's going to enable a wide amount of use cases, a wide amount of industries, and your idea is to actually have collaborative software projects like etcd that are fundamental components that are used across the industry, you actually need to take open source a step further and go into open governance. And that's really the point of the CNCF, is that this is a body that's a neutral body. It's supported by the industry. So different companies, AWS included, we're a sponsoring member of the CNCF, and we help sponsor them. We help them complete their mission, as do many other technology companies, big and small, and users. Actually help further the CNCF. And so the CNCF acts as this neutral governing body that helps to implement open governance on the different projects that are open source projects in the world. And so we're really excited to talk about etcd today. We're going to dive into that in a second. etcd is one of 14 currently graduated projects within the CNCF. And what it means to be graduated is really, it's a maturity level, it's an adoption level, right? So there's this concept of this like bell curve of adoption, and the amount of people adopting something in a given technology space based on how mature it is. And so the idea is that, very early on, this is like kind of like prototype type of an idea, and you're going to get these early adopters, like the techies, the people that are really, love to just get their hands into the latest and greatest stuff, even if it doesn't quite work right. And so the CNCF has this concept of like a sandbox project, these really early stage ideas. And in AWS, we've actually recently donated a project, the CDK for Kubernetes, to the CNCF sandbox. Early stage, experimental, being used by a few people, it's developing. And then there's this idea of innovating, which is like, okay, this thing's production ready, a few people are starting to use it, we have some actual traction, it's being adopted in the market. And that's where etcd was for a long time, and has been incubating for the last few years. It's been a core part of Kubernetes and other things that I think Gyuho will talk to us about. And then the idea is that, okay, once we kind of like cross that chasm, and there's actually a great book on this called Crossing the Chasm. Once we kind of cross that chasm from, this is something that a few people are trying and using in a few places, to really, this is a fundamental piece of technology. The majority, like there's an early majority of people that are really using this, and it's really well proven, not just in terms of like stability, but also in use cases and functionality, and has a solid community around it and a good development life cycle around it. Then that's what it means to have like true, product market fit, true adoption. And at that point, that's when a project becomes graduated. And so that's really what we're talking about today with etcd, is this fundamental piece of technology that's an important part of both the Kubernetes project and is used by many other companies and other in other ways has sort of reached this maturity stage in both technological and adoption maturity, and is considered graduated by the CNCF.
Wow. Yeah, that's
It's a lot.
that's a lot. But I mean, let's talk about for a second how important etcd is. It is, Gyuho, what is etcd and how are we using it today?
Yeah, so yeah, etcd is an open source now CNCF project. As Nathan said, it is a graduated project, which we can talk more about the process. But at a very high level, it is a consistent distributed key value store. So we mainly use etcd as a separate coordination service in distributed systems. So etcd is designed to hold small amount of data that can fit entirely in memory. So although we still write to disk for durability, like obviously, but like you still do not want to store all of your applications data in etcd. So for typical etcd cluster, like it's distributed over 3 to 5 nodes for high availability, and while we prioritize consistency and then partition tolerance. So which means it is to provide one logical cluster view of many physical servers. And then as long as the majority of the cluster is up, etcd should continue to work. So when I say majority, we say cron. So when you have a 5 node, it will be like any 3 node. When you have a 3 node cluster, it will be at least 2 node. So this redundancy provides us with the fault tolerance. But you may think, what does etcd have to do with the containers? So yeah, etcd is a coordination service that stores the cluster metadata, like mostly internal to the distributed applications built on top of etcd. And mostly used for clustering service and the service discovery and the database applications. So for containers, Kubernetes is the most popular use case. So also Nathan said Kubernetes is another open source project that Eks is built on top. So Kubernetes is a cluster management system for containers, and the Kubernetes control plane interact with etcd. So for instance, Kube API server persists all cluster metadata in etcd. And then the kubelet or node agent can subscribe to this information. And then etcd has a watch API. Think of it as a push model. Like whenever changes happen to the node object, etcd notify the client. And then that etcd client is embedded inside the Kube API server.
That's nice. So every time that, a lot of people comment, for example, on how fast a deploy happens in the Kubernetes world. And that's probably partially, at least in part, due to that subscribe model that you're talking about, where kubelet, and really it's the etcd client inside of kubelet, is subscribed to the node object in etcd. So as soon as there's a write to that node object in the database, then immediately the client of that is notified and can start to take action and do whatever needs to be done. So etcd is obviously important. Obviously now, it's reached a level of maturity that allows us to call it, graduated and all that. I am aware of it acutely because of, being a Kubernetes user and an EKS user, but are there other uses? Are people using this outside of the Kubernetes world?
Yes, yeah, we have a lot of adoptions out there. So etcd is quite popular open source project. So if you look at our GitHub page, it has more than 30,000 GitHub stars. And then there's a website called dbengines.com, and they're ranking etcd as most popular key value store in the coordination space. And then also, as we mentioned, Kubernetes relies on it, and then we also have a lot of non-Kubernetes use cases. So on top of my head, the NTT, the Japanese telecom company, using etcd to manage their networking infrastructure. And then Uber also using etcd to manage their time series database. And then Braintree also using SCD to power their caching systems.
Wow.
And then recently, like Cloudflare, I discovered that they're using SCD internally to manage their core data centers. And then also a lot of startups like a Tailscale is a WireGuard company. Yeah, recently they are using SCD for their a testing as well.
Huh. That's awesome. So we're going to get into a couple of specifics later, but I want to throw out before it gets too far scrolled by. How Texan Raj asks in chat, how big is the etcd typically for, say, 100 nodes? And when you scale to 1,000 or thousands, how big does it grow? And maybe I know that there's not like a simple metric on this. I know this is really more of a question of performance of etcd. So talk to me a little bit about what has changed over the past couple of years. We launched EKS a couple of years ago. You joined the team a couple of years ago, but you've been working on etcd for longer than that even. But just in the past couple of years, what is different when it comes to etcd, and how have things gotten better?
Yeah, so I can talk about that. Also, I can comment on the question really quick. So let's say you have a right-sized instance types for each etcd node, and then there's no resource limit. Given that said, you can easily scale etcd to support up to 10,000 node. And even the official Kubernetes clustering guide recommend that you can run up to 5,000 node. So to your question, 1,000 node should be easy to support. Of course, it depends on the type of workload you are running with the 100 node, but at the high level, 1,000 node is supported. And then back to Brent question, what has changed in the etcd upstream? So in the past 2 or 3 years, now etcd is a very stable project. We're not really working on shiny new features because it's a core to other distributed systems. So we spend most of our time optimizing and then doing the bug fixes. But one thing that comes to mind also for the operation side. So when you operate etcd or any distributed systems, it is critical that you maintain those state across all those nodes and then keep them in sync. And then etcd also support dynamic reconfiguration to adding the new node or removing old node. So when a server added to the new when a new server added to the etcd cluster, it does not contain any previous log entries. And then if it is added to the cluster in this state, its logging could take a while, and then to catch up to the leader's entries. So during this time, leader has to send snapshots or log entries to the new node, and then this can overload the overall cluster availability. So for example, 3 node cluster can normally tolerate one failure, with no loss in availability. But however, if a fourth node with an empty log, which means no data, is added to the same cluster, and then one of the original 3 servers fail, you already lost 2 out of 3. So in this case, the cluster will lose the availability at the moment, and then unable to process any client request, even the readings.
So that communication between those servers is happening over the Raft protocol, right?
Yes.
I know the Raft protocol is actually used in a few different projects. Why have people picked that, as the preferred way to replicate this information? What's great about the Raft protocol?
Thanks for mentioning that. I forgot to explain what do we use for our replication protocol. Yes, so etcd use Raft to replicate the log entries between the node, and then we choose Raft because it's that's the whole point of Raft. So if you know Paxos, Raft is basically a multi-Paxos instance. And then they just like make it easy to understand and then make it easy to like implement. And then it's more practical, like focusing on the series of log entries, like whereas the Paxos is more focusing on the like a single entry. So I would say not just for the not for the performance. In the Raft may be slow in terms of performance, but for just like easy to maintain, and then it's less complicated to like maintain like going forward. So that's why we decided to go with the Raft instead of Paxos.
Yeah, and my recollection, and you correct me if I'm wrong because there's a good chance I will be, is that Raft helps when it comes to scale, because normally if you're talking about a traditional replication model where you might have a leader and then everyone has to replicate off of that leader, you have like 10, 100, 1,000 nodes, 10,000 nodes, all trying to read from that same leader. Whereas Raft allows there to just be consensus among a smaller group. And so that, data kind of filters down and eventually reaches every node. But because it's not all depending on one single node, then it's able to scale out much more broadly without causing a whole bunch of heavy intense processing on behalf of that one node.
Yeah, so the answer is yes and no. So we choose Raft, and that Raft can give you the better performance is distributed, as you say, and then each node can serve the read. But if you want the latest data, not the old data, and if you want your like a read to be like up to date at all times, it still has to go through like communication between leader and then followers. So in that case, if you want the strong consistency, the Raft doesn't necessarily give you the better performance. It may just much slower than just reading from the single node. So the point of like being distributed is just giving you the higher availability. So in case one node goes down, like if that node happens to be the leader, we can just fall back to the other node to elect a new leader and then just continue to work.
Awesome.
Yeah.
So I know you said you work on the Kubernetes team. You're, a maintainer of etcd. What's your day-to-day like? What are you working on? What are some horror stories that you may have seen, in your job here at AWS?
Yes, yeah. So I'm the lead maintainer of etcd along with many other core maintainers. And then for etcd, I oversee the whole project, like from storage layer to replication layer for the Raft, and then also client implementation. And then I'm also managing the release and then like a patching process. So, and then at AWS, yeah, we are funding etcd development and then also testing like through the CNCF. And of course, etcd organization like support my like open source work on etcd and then any other like related open source project. So yeah, so for Upstream specifically, the last major component that I worked on was to improve the etcd client implementation, like make it more reliable and then resilient, like in case of like data center failures. So like right now, like when you give them multiple etcd server endpoint to the etcd client, now etcd client can now perform some automatic retries and the failover. And then yeah, so working as an open source maintainer like at AWS and then also at the same time service team member at AWS, yeah, it is definitely like a different experience. Like before AWS, like I was at the CoreOS, and then I was like primarily focusing on the developing etcd software itself, but I wasn't actually using it in production. But at AWS, like we engineers own the product, like and then design, and then operational side end to end. So yeah, this is definitely helping us and then the project in the long term, and then we work very closely with the customers and then get to experience all the operational issues at like firsthand. And then for open source, we take the feedback back to the community and the project, and then to make it better.
That's so cool. I mean, and it's, we talk about it, but it's awesome to hear from you, you know, on the engineering team, actively doing this every single day. So that's great. And again, it's such a core component to something that, you know, so many customers use. So the improvements that happen, you know, are just awesome because they're so impactful. What's on the roadmap for etcd, or what's in the future? I know you mentioned that it's you're not going after the new flashy stuff anymore. It's pretty stable, but what are some things that you are still working on?
Yeah, so yeah, maybe I can like finish explaining the like kind of like a new feature we just added to the latest release. So yeah, when you add a new member to the new cluster, the member joins with empty data. And then they can overload the leader node in etcd. So yeah, and then they can also cause some like availability issues. So in order to avoid those availability gaps, etcd introduced an additional like a member phase before the configuration change, like where the new server joins the cluster as a non-voting member. So you can think of it as a standby node. And then when you join as a standby node, the leader still replicate the log entries to it, but the standby node does not yet count it towards the like quorum for voting or commitment like purposes. So like when you have it, you can just wait until the new server has caught up with the rest of the cluster, like without like too much disrupting the cluster availability. So yeah, that's the latest feature we added. And then also for the last release, yeah, we did a lot of like a small optimizations to our disk, the low level storage backend. Yeah.
Very cool.
Yeah, so that was mainly driven by the like Kubernetes use case, like which was cool.
Yeah. So I know, you know, we've had other guests on the show who've mentioned that, you know, we're working on scaling for Kubernetes and, you know, trying to push the limits in scale. And I assume etcd is, you know, going to be a core participant in that kind of stuff too. Are there any stories you can tell about, you know, operating at high scale? What would you consider to be a big etcd cluster, and what are some things that you would have to watch out for? Oh, you muted.
Okay. Yeah, let me see. Yeah, so yeah, there's some like one interesting story. Yeah, before we talk about the scalability. So yeah, I was like on call, and then let's see. Let me see. Hold on. Yeah, so any interesting etcd use cases are mostly from etcd like Eks, the service team paging alert, and then where we had to do some emergent like operational fixes. And then yeah, it was definitely not fun like back then, but yeah, I won't disclose which project that the customer was using, but there was one software that had a bug that did not properly configure its object keys to etcd. So they had defined their own revision, like just like incremental index and then key space. So the way they defined the revision was to generate different key suffix for every single like a change. But as a result, every time customer make changes to their path spec, it create a new key, rather than overriding the like a same key. So to give you some background, etcd support like etcd retain all the historical values. So there's no like not really like reason to keep separate keys for the same path. You can just like specify the resource version to fetch the old values. So anyways, so their database size like quickly like grew beyond our limit. It was actually over like 6 GB, which was pretty high, given the default etcd database size limit is 2 GB. So yeah, we had to engage with customer to help them clean up some resources that they don't need, and then guide them to update their software with the bug fix. Yeah, it was actually the open source project from third-party vendor, and then they already had a bug fix. Like the customer was just using the old version. But yeah, so yeah, that was interesting to see. Like when your software give you the freedom to write any kind of workload, there's always a way to break the software.
Wow, that's pretty cool. And that's the kind of thing that you probably wouldn't see if you're an average, customer that's using Kubernetes yourself, do it yourself Kubernetes, or even especially using EKS. But Nathan, tell us, is this why people should use EKS?
Yeah, I mean, that's really what it comes down to, is that etcd is super powerful, but at the end of the day, it's one of the components that customers have to run Kubernetes, and we have a team, Gyuho and the rest of the team that work really, really hard on behalf of customers to run the Kubernetes clusters, all the components that go into running the Kubernetes clusters, to test, to optimize, because it's not just operationalizing, right? But every version that we run, when we run etcd, we're testing those configurations, we're validating those things, we're testing them at scale, and we're running the way that we run that across thousands and thousands of customers. And that's really hard work. It takes a lot of people like Gyuho that are really dedicated and put in a lot of hours, and wear pagers and wake up in the middle of the night when things go really, really wrong. And I think that's one of the big values, right? Is that AWS spends a lot of time, and the EKS team spends a lot of time making sure that this stuff works really well for our customers day in and day out. So as a customer of EKS, as someone that's looking to run Kubernetes, you just log in and press a button or make an API call. And then on the back end, there's a ton of work that's being put in by our team to make sure that that's a really great experience, that you have a Kubernetes cluster that's highly available, that's highly performant. We're taking care of some of the really complex components that go into running a production-ready Kubernetes cluster.
Yeah, and it's just whenever I was prior to coming to AWS, right? I've Brent, we've managed our own environments in AWS large scale. And I was laughing while Nathan was talking, because I was thinking in my head, I've built and managed clusters on my own. And when I have to go in and troubleshoot, I don't have the level of depth like someone who's on the EKS team, who's the core maintainer for etcd, who knows etcd inside and out. I trust him way more than I trust myself. So it's just, again, when choosing, do I build myself or do I use a managed service? You think about the moments when things go wrong. Who's better suited to troubleshoot and dive in? And usually it's not me, right? It's the person. That's one of the huge benefits of using EKS and using managed services in AWS. So
exactly. And Tex and Raj brought it up earlier. Is there a plan to provide etcd as a service? And I think standard answer is probably let us know what your use case is. So, I would love to find out from you how you would use such a service, because we won't rule it out, right?
Nothing's ever ruled out. We have we do have an open source roadmap on GitHub that we'd love to have your comments and your use cases on that. I would say right now, the etcd that we run is really built and optimized around Kubernetes and running around EKS clusters. But yeah, never want to rule anything out, and would love your feedback on this, but then also other things for container services on AWS as well. There's open issues on the roadmap there, and we read these really regularly and try to stay active here on GitHub. So would love input there.
Absolutely.
And so I would like to ask, Gyo, okay, so you work on EKS, primarily, right? You're supporting EKS, etcd, and EKS. But if I was someone who was managing Kubernetes on my own, maybe are there some maybe top 3, tips you'd give to someone managing etcd on their own, maybe some best practices you can maybe throw out there?
Oh yeah, so I think when you run etcd, even AWS, like anything can happen in the data center. So I think having the periodic backups is like critical. So we do that for EKS. We do that, like we do the periodic backups and then upload it to the S3. So I think the disaster recovery story will be the top. And then also, I think the trying to understand your workload, because sometimes even for us, this is very challenging to us. Like when you have a large number of nodes like running at the same time, and then somehow etcd can just stop working or grading in its performance for not clear reason. So having the metrics collected in place and then trying to understand how to read etcd server log, that will be very helpful, so that you don't need to go to the wiki or GitHub pages to handle all those production issues. And then we also have a benchmark tooling in Upstream. So you can just sort of simulate your workload using those tooling. But other than that, so keeping those etcd cluster up and running, it's very challenging problem. When you have only one cluster, it's fine. But when let's say you have more than 100 clusters, it's getting really hard.
I bet. So I have a question.
Yep.
etcd is an in-memory distributed key value store. There are others. There's Zookeeper. You could maybe count Redis sort of in that same list. How do you know what to choose? If you're just gonna go out, I'm gonna start a project and I need a key value store. I know you'll choose etcd probably, but what are the decision points that would lead you to choose etcd or choose something else?
That's a very good question. So so that question would be same as when would you choose the Paxos or Raft, versus the other? So as we discussed, etcd is built on top of Paxos or Raft, and then when you have a consensus layer, in the replication layer, it can add you the latency, but it also give you some kind of strong consistency compared to others. So as I understand, Redis was built first for the single node. I think they now have a distributed the feature, but when you need a strong consistency for your coordinating your distributed applications, and then if your a data set size is under, let's say, 2 GB, but still a mission critical to your a workload, then I think etcd would be the a best choice. But let's say when you need more than 100,000 write throughput, and then maybe you don't really need the strong consistency, maybe you can just go with the Redis or other database.
Okay, it's good to know.
Yep.
Awesome. Is there anything else that we should mention to our audience? Any new etcd information or things to be on the lookout for, or anything like that?
So I just wanted to mention. I just wanted to mention one work we are currently doing. So as Kubernetes has grown its popularity, the scaling beyond 10,000 node is a lot of customers asking for it, and then a lot of users in open source trying to do it. There's some open source blog about it, but for EKS, so for EKS definitely pushing etcd beyond its scalability and the performance limit. And then we are performing some a scalability test with more than 10K node. And then we found several issues that were considered a theoretical edge cases. And then one example would be, so deflect operation. So which is a process of rebuilding the database file in order to reclaim the disk space from the SCD storage layer. And then by cleaning up the fragmented file. And then this was very like a disruptive operation, but it was required to keep the database size like compact. So yeah, we found this issue when there is an ongoing defrag like operation. We found that there is a possible data durability issue where the low-level storage layer does not track its pending entry, like pending applies like properly. So yeah, right now, yeah, I just wanted to mention we are working on the fix, and then as a community, like we are also working on like improving the scalability of SCD and then Kubernetes control plane in general.
That's awesome.
Yeah.
And I know the etcd project, you guys are always looking for contributors. So, you know, if this is something that interests you, how can people get involved?
Yeah, so you can reach out to me via like GitHub, and then obviously, yeah, we are like hiring. So like if you wanna join us, like working on like SCD and then its operation at AWS scale, yeah, you can reach out to us via like SCD or reach to me via like a Twitter or GitHub.
And is that your Twitter handle?
Let me share. Yeah, my Twitter handle is Gyuho Eks.
Ah, nice.
Yeah.
Awesome. Nathan, any departing words of wisdom from you?
I think Gyuho's handled it wonderfully. Yeah, just really excited, you know, for general EKS project, the link we shared earlier for the public containers roadmap, definitely something to check out. We keep that up to date. You can also submit issues, requests, questions there. You can also reach out to us on Twitter. And yeah, really happy that everyone was able to join today, and excited that we got to kind of deep dive into this really important technology that's part of Kubernetes.
Awesome. Well, Gyuho, thank you for joining us and enlightening us. This was fantastic, and congratulations on graduating. You know, I don't get to talk to many graduates these days, so good job. I feel like we should have a move the tassel event or something like that. But congratulations, and you know, keep us posted on interesting things that are happening. This was awesome, and this is such a core service that, you know, it's easy for it to go unnoticed because it runs so well. Yeah. So good job.
Yeah. I just want to add, you know, our goal with the show is, as we, you know, throughout the year, we want to bring on more, you know, engineers from our service teams to really talk to us about the core technologies, the cool things we're building. So this was just a start to, you know, really more quality content coming out. And Gyuho, super awesome. Thank you so much for giving us that level of depth that, frankly, Brent could probably do a decent job on, but I would not have been able to go anywhere near.
No, I mean, obviously I got Raft wrong. So
go back to the drawing board. It's going to be great. So anyway, but so as far as the show this week, I think this is it. You know, unfortunately, coming back from, you know, the past couple weeks, holiday breaks, some people got sick, you know, this and that. So this week, this is our only show, but we plan to get back on more regularly scheduled airings beginning next week. So Thank you guys again.
Cool.
Thank you all.
Thanks, everyone.
Thank you.
Bye now.